Hey there everyone, welcome to this video, one of 3 videos for my physics people to help us critically think, quote unquote, in our tests so we don't completely fail. This first video would be dealing with how to approach question, especially the questions we get in quickfire multiple choice where we don't have much time to think about what we have to do, but we have to do it or we fail. So let's get started. So the 3 main things we're going to look at when we see our question, because we only have about 15-20 seconds to look at our question, we're going to identify the question, essentially. We're going to look at what the question is, what the answer is, and how the question and answer are related. And it sounds pretty basic, but it does help to go through these steps in your mind, at least for me. I'm not exactly a trained professional or anything like that. If you're wondering on YouTube, this is just a random person doing a video, so don't. But yeah, those are the 3 main things we're going to look at, and I'm going to show you an example because I think that's the best format for you to really understand what I mean. So yeah. So I'm going to use questions from class to make it more applicable and so you could see what you could have done if you remember that question. So this one's from the 6th of February. I think we were in the music room. A boy throws a ball of mass 0.01 kilogram vertically upward with a speed of 10 ms negative 1. Acceleration due to gravity g equals 10 ms to the negative 2. And that's the basic question before you get into all the parts. Now, what you're going to look at is what they give you. In another question, I'll show you how you do it all at once. But right now, you're going to say, first of all, you know, the ball has mass 0.01 kilogram. Write it down somewhere. I'll probably put it up on the screen. And it's going vertically upwards. So there's no real vectors, it's just going up. The speed is 10 meters per second. And the acceleration due to gravity, which is counteracting the speed because it's going vertically up, would be 10 meters per second squared. Now we can get into the parts of the question. So the first part says, calculate the initial momentum of the ball. Now, I hope you're basic physics students, so you should know this. Momentum is equal to mass by velocity. So, looking back at your initial question, you have a mass and you have a velocity. So, you plug that into your values for momentum, and that would be your answer for the first part. Part B, calculate the time taken for the ball to reach a maximum height. Right, so, this is where it starts getting a bit more tricky. Now, I'll go through this like this. Essentially, you have the values. In this case, you're looking at speed and stuff like that. So you have the values 10 meters per second and 10 meters per second squared. 10 meters per second is your velocity or speed. Well, it's your speed. 10 meters per second squared is your acceleration. And you want to find time. Now, what you're going to do is that looking at what you have and what you want, you have to find the relationship between those 2 things. In this case, acceleration is equal to velocity over time. So, acceleration by time is equal to velocity, and time is equal to velocity over acceleration. And you're going to have to get used to doing that in a shorter period of time, but right now I just want you to get used to the thought process of it, looking at and breaking down those values that we get in class and notes and don't really comprehend too much before we get these kinds of tests. So in this case, after you say time is equal to velocity of acceleration, you plug in the values and you'd end up with 1 second. So part C of the question says, the boy catches the ball. Sketch a velocity time graph to illustrate the motion of the ball. So in that graph, of course, you would have velocity, which is meters per second, and time, which is just seconds. And from the initial question, which you're now relating it to, you have velocity and acceleration. Now, what you know is that ball was thrown directly upward, so it's going directly against gravity, vertically upward, and gravity is acting completely opposite to it, downward, in acceleration form. So, it's taking away from the velocity of the ball. If that acceleration is increasing, it means that it's pulling more on the ball as it gets further up. I hope that makes sense. So, the ball going upward would get slower and slower, uniformly, because it's one acceleration. It's not changing acceleration. So it'll be a straight line downward. And after 1 second, which is what we calculated in part B, it would just stop in midair. That's the point where it just the velocity upward is equal to the velocity downward. Then after that, velocity will increase again because now it's accelerating due to gravity directly. And it'll go back up in a straight line. I'll try and put that on the screen as well. So, part D now, which is, I'm looking at more of the worded questions, which is why I might have skimmed over C a bit, because that's a graph and that's a whole nother story. I'm not sure if I can explain that very well to you. But part D says, state how you would find the maximum height reached by the ball from the velocity time graph. Now, that would mean that, as you know from us working it out in class, the area underneath the velocity time curve, quote unquote, would be equal to the distance traveled by the object. And we calculated that in C above. I'm speaking, how is it supposed to be above? Anyway, we calculated that in C. And essentially what would happen is that you find the area of the triangle underneath the portion before it reaches 1 second, which is where it just stops in midair at its peak. And that's pretty much it. And then, well, part E, since it just said state how you would find, part E is actually determine the maximum vertical height reached by the ball. So this sort of stepping you on. Now that won't happen much in multiple choice, and unfortunately I don't have any of those multiple choice questions to help you with. But I will go on to a question for you to do on your own in a little bit and see how well you guys do. So try to go through those steps in your mind when you look at a question. Look at what you got, what you need to get, and then try to figure out how those two are associated. That's the main thing I'm trying to get across. I know I ramble a lot, so I'm not sure if I got it across very well, but we'll see. I'm going to do number 7 from, I think it was on the phone. So, yeah. Okay, so now I'm going to give you a question on your own. This is number 7, sent on 15th of March at 16:02. And I want you to try it. Please don't skip it, because you'll never learn if you don't try it. You can make as many mistakes as you want here. Finish the question at the very least. Because you're not going to get this kind of time where you could sit down and pause this for however long you want in exams. And we know that. So I'll put it up on the screen because I don't feel like saying it. And I should put it up on the screen anyway. And I'll leave you guys about 5 seconds here to look at it and pause the video. Pause it. I see you trying to run through and listen to the answer. Pause it. Good. Okay, 5 seconds starting like now. Aha, it's more than 5 seconds. You should be happy. Congratulations, you did very well. You probably got it out. You guys are smart. I'm not laughing. You guys are actually smart. Now, I'm sure you're just playing this video not because you just want the answer, but because you just want to make sure your method is sound. Good job. You did well. 10 marks for effort. That's an A for effort, guys. Okay, yeah. I'm done joking around. Well, I won't bother saying the question because it should be already up on the screen if I'm any good at editing. So, the effort, which is part I. By the way, they shouldn't have a question mark on that line. Let me just say that. Okay, yeah. Part I. The work done by the effort would be 200 by 1.5 because you're going from 200 newtons, 1.5 meters. That's the effort. They say it's the effort there. And then you have the load, 600 newtons by 0.13 meters. So, you are looking for work done. And work done, the unit of work done is joules. So you're converting from newtons and meters to joules. And joules is a newton meter. Make sense? Didn't confuse you? You good? You good? Good. So by the effort, you have 200 newtons by 1.5 meters, which would be, I believe, 300 newtons. 300 joules. Should have corrected me there. And part II, the work done on the load, would be 600 by 0.13, which is 78 when I work it out on my calculator. So that's 78 joules. And the efficiency is essentially the output power, well, the output work over the input work multiplied by 100 to make it a percentage. And in that case, you would get... I'm actually working it out because I don't have... around 26 should be. If for some reason I did my calculations wrong, but I got the method right. Well, I think my method's right. I shouldn't be doing a tutorial if my method isn't right. But if you guys did the correct calculation, just comment it or something. But yeah, that's what you should get. And that was your example question. You could do some more. I'll probably just go through all the old pictures on the chat, not the memes. But yeah. So that is essentially the first video. And if you need any clarification, because I really need to get some better questions for you guys, but that's essentially what I'm trying to explain. So I will see you in the next video, which will be, I believe, applying theories. And I hope you have a nice day and stuff. Hope you understood physics and had fun and going to pass all your exams. Bye.